All right, welcome back to Database History. In the world of data, you run into some problems that are just so big, so complex, they completely break the rules. Today, we're going to look at the tool built specifically to handle that kind of chaos, TileDB. And trust me, it's way more than just another database. It's a whole new way of seeing data.
So let me start with a puzzle for you. How do you actually store a satellite image or a DNA sequence or, heck, an entire AI model in a database? I mean, really think about that. We're not talking about simple spreadsheets anymore, right? This is the kind of data that is literally shaping our future. And the old tools, they just can't keep up.
Yeah. The simple truth is, you can't. At least, not with the databases that most of us are used to. Trying to force this kind of data into neat little rows and columns, it's like trying to flatten a globe onto a piece of paper. You just lose all the important stuff, the very structure that makes it valuable in the first place. This data has shape, it has depth, and it really needs a home that's built to respect that.
And that is where our story really kicks off. The answer to this problem, it didn't come out of some big corporate boardroom. Nope. It came from the labs at MIT, where the data they were working with was just so incredibly complex, they had to literally invent a new way to hold it all. This is a story about building the right tool for the job, especially when that job is, understanding the universe.
So it all started out as a research project at MIT's famous Computer Science and AI lab. Then, flash forward to 2017, and it spins out to become its own company, TileDB Inc., and they were just laser-focused on one mission: build a universal data engine that could finally wrangle all these crazy complex data sets. And today, well, it's become an absolutely critical tool for scientists and data engineers all over the world.
So, what's the big idea here? What's the secret sauce that makes all of this possible? Well, it's actually kind of simple, but it's also incredibly powerful. It all comes down to one thing: the multidimensional array. See, instead of trying to force data into a structure that doesn't fit, TileDB just embraces its natural shape. It uses the multidimensional array, which is basically the native language of science and AI. So whether you're dealing with a dense grid of pixels from a satellite image or the sparse, spread-out data from a social network, TileDB just sees it for what it is.
And this really shows you the core difference, right? On one side, you've got that rigid, flat, two-dimensional world of rows and columns we all know, but on the other, you have the flexible, multidimensional world of arrays. It's a huge shift in thinking. We're moving from just organizing records to organizing actual scientific objects.
Okay, and this is where it gets really exciting. Just think about this for a second. We can store an entire genome as a single, searchable object. We can treat a satellite image not just as a flat picture file, but as a cube of data that you can slice and dice any way you want. You can even store the brain of a machine learning model. This isn't just about storage anymore, it's about having active, intelligent data. So, okay, this isn't just some clever idea that never left the lab. Let's actually look at how TileDB is being used out there, in the real world, to tackle some of the biggest challenges we're facing today. I really love this quote because it just gets right to the heart of it. TileDB isn't just a bigger box to dump your data into, it actually provides an intelligent structure for that data. That means it's organized, it's accessible, and it's ready for you to work with from the very second it's stored.
And you know that intelligent structure? It's attracted a list of users that reads like a who's who of innovation. You've got NASA using it to model our planet's climate. You've got Regeneron using it to unlock the secrets of our DNA. From Wall Street all the way to the world's top research labs, TileDB is the engine behind some seriously groundbreaking discoveries. This is really where the rubber meets the road.
Okay, so for those of you who actually work in the data space, you're probably wondering, hey, how does TileDB fit in with other formats I already know and use? That's a great question. Let's put it all into context.
All right, let's break down what makes TileDB different. So you take something like HDF5, which has been around for a while. TileDB is cloud native, which means it was designed from the get-go to work perfectly with modern cloud storage. Then you've got ZAR. Well, TileDB is generally more scalable, so it can handle these massive enterprise-level data sets without even breaking a sweat. And what about Parquet? Parquet is fantastic for tables, no doubt, but TileDB is truly multidimensional. It lets you work with that complex data in its natural shape. And look, it's not about replacing everything, it's about having the right tool for the right job.
And one of the best parts about TileDB, for me anyway, is that it's not some lockdown proprietary block box. It's open source. And that means there's a whole global community of developers constantly making it better. And hey, you could even be a part of that. And this isn't some isolated tool that's going to force you to change your entire workflow. Not at all. It's designed to integrate seamlessly. It has fantastic support for Python, R, C++, so it plugs right into the languages that data scientists are already using every day. It runs on all the major cloud platforms like AWS and GCP, and it works beautifully with tools you already love, like Jupyter.
And getting started is actually pretty straightforward. First, you can go explore the project on GitHub. Then, just pick your favorite language binding, Python, R, whatever, and start coding. From there, you can start integrating it with your own cloud data stack. The whole thing is designed to be accessible.
So there you have it, a new kind of tool for a totally new era of data. We've seen where it came from, how it works, and the incredible impact it's already having out in the world. Really, the only question left is, what problem will you solve with it? Thanks for joining us on Database History. Now go build something amazing.